Okay, so in this example, we're going to go over a proportion test. All right, so this is number 100 in our collaborative statistics and a textbook on the hypothesis testing chapter. So, according to an article in Bloomberg Business Week, New York City's most recent adult smoking rate is 14%. Suppose that a survey is conducted to determine this year's rate. 9 out of 70 randomly chosen NY City residents reply that they smoke. Conduct a hypothesis test with a 5% significant rate. Okay, so, actually, I kind of left off something here. So, to determine if the percentage of smokers, I forgot how to spell here, percentage of smokers is less than 14%. Okay. Okay, now a couple things that should stand out here is that we don't have a population, or excuse me, any kind of mean, right? We have a percentage, right? So if we're given a percentage, or we're told that X amount of some larger value, then that should tell you that it is a population proportion, right? Where we ask an individual, right? And in this particular framework, right, we say we have two options, right? It's a trial, right? Each individual represents a trial, right? Where we ask them, do they smoke, right? And the way that it's framed, a success in the trial would be that they do say yes, they do smoke, and a failure would be, oh, actually, we do not smoke, right? So what is known, P, is 0.14, right, from our 14%. All right, so that's the probability of success, right, from previous knowledge, right? We're assuming that this is the population proportion, right? So Q, which is 1 minus P, would be 0.86, right? Or there's an 86% chance that if you ask any given random individual, that 86% chance they do not smoke. All right, so some data was collected, right? So 9 out of 70 randomly chosen residents reply that they smoke. So our data, X successes, 9 out of the total, our sample size is 70. All right, so as long as the sample size is large enough, and this would be, right, usually you take n times p, and that's greater than 5, and we don't have any problems here. So here, 70 times 0.14. Okay, so n times p is larger than 5. When you multiply by 0.86, it'll definitely be larger than 9.8, so definitely larger than 5. So what that tells me is that we'll use the normal distribution. All right, and we want to conduct it at a 5% significance level. All right, so here we want to make sure that our data is, we're at the 5%. Right, where our population proportion here is 0.14. Okay. All right. So our sample that we've taken, right, we'll have P prime is 9 out of 70. That's 0.129. And Q prime would be what the rest of this, right, which is what, 61 over 70, which is 0.871. All right, so I've identified any relative information here. So the next thing is I'm going to let my calculator do the rest of the calculations. All right, oh, excuse me, this is less than. What am I doing here? So here, this is not the test that we're conducting, right? it is a left tail test, right? We're assuming that it is less. Okay. All right. So my apologies. Not that one. Sorry. So it is on the left tail. Okay. So in terms of now, let's do the calculations, or let's let our calculator do the calculations. So we go again to stat. We scroll over to test, and notice here number 5 is prop. So proportion z-test. Hit enter. Okay, and here this one's already populated from the previous. I did it earlier. One thing is I do have to change here, so 0.14. All right, our data 9 successful trials out of the 70 trials. And one thing I need to highlight here, two-tailed. This is going to be left-tailed, right? So I chose the middle one, and then we calculate. Okay, and get our z-score. And again, so this tells me in terms of, so the z-score again, we always interpret as the standard normal, right? So it's only not even one standard deviation based on the data that we found to the left of the mean, right? In other words, right, this p value, right? So our p value, not to be I know it can get confusing. The p prime, right? That's simply the 9 over 70, but this is our p value, where it's just p is 0.39, right? So what that tells me is that this is actually not an uncommon result to find, where we have 12%, right? Instead of the 14%. So there is not enough evidence here to support that the claim is smaller, that the population percentage of smokers is smaller than 14%. Right? So here, so p-value, right, compare it to our alpha value, which we wanted to 0.5. This is much smaller. So this is not a rare event, this information that we gathered. So what we conclude here is we do not reject the null hypothesis, which means there is not enough information to accept the claim that p is less than 0.14. Okay, so actually I should have done this at the top. All right, so H0 HA p is less than 0.14. Okay, now again, we have not confirmed that the population proportion is 14. That is not the purpose of the hypothesis testing. All we're saying is that there's not enough information to say that it's changed, so we just continue as before. But it's not a confirmation of previous results. It's just simply stating there's not enough information to claim to verify that it has changed.